In all of these forces, not only biological but also figural, physical, visceral issues of architecture, watched him shaping buildings of immense presence. It's an extraordinary voice. And I must say that it is also in many ways a loving tribute to the influence of Ron Heron. Nowhere does the Heron legacy exist with such sort of sensitivity than the work of Ken Yeang. So it's with great pleasure that I want to introduce Dr. Kenneth Yeang.
Thank you, Alan. Thank you for coming to my lecture. I have to give tribute to Ron, who was my third-year master, who saw me through part 2, and also to John Fraser, who's been my supervisor, who was in Cambridge, and he gets very annoyed if I don't give credit to him, so I'll so I have to. Sorry. We started doing tall buildings about 18 years ago when we started practice. Foolishly, we started practice almost after we left school, and we had to learn everything on the run, so to speak. Not just designing buildings, but putting buildings together, but also learning how to start a practice and to run a practice. We were thrown in a situation where we had to do a lot of buildings very fast. And in the last building boom, we must have designed about 20-25 skyscrapers and built about 9. I think in this building boom, we probably built about 12. You have to remember that we're working in a very fast-paced situation where the client will give you the project on Friday and expect a complete set of plans for a 250-room hotel by Monday morning. And also, we're working in a situation where the bottom line matters. And so we had to develop a method of work that would enable us to do architecture and keep the business going at the same time. So we focus on tall buildings because I believe that you have to, whatever you do, you should do it well and not do too many things at the same time. Sorry. Now, when we started doing tall buildings about 18 years ago, we had no models to go by. All the models we had were from the West or from America, because the Americans invented a skyscraper. And so this is Houston here. And you can see, cities are growing so fast, and that in the year 2000, most of the biggest cities in the world will come from Asia. This is New York, and you can see Singapore, which is very similar to the Singapore on the right here, which is very similar to Houston in many ways. Of course, the Americans romanticized the skyscrapers. This is the King Kong. Of course, we contend that skyscrapers, the Chinese built skyscrapers as well. They built pagodas, and this is a 13-story skyscraper, if you like, built by the Chinese. And we did experiments with skyscrapers. These were some of the studies we did with the students at the University of Hong Kong, looking at different shapes and different forms and different ways of bringing cross-ventilation into the buildings. And we conclude that a skyscraper, like it or not, is an international piece of machinery that every country in the world has. Like it or not, has. Even the poorest country in the world, Bangladesh, have skyscrapers. But similar to the 747 or the airplane, I mean, the 747 is it's like a sort of 20-story building, and it's made of bits and parts taken from all over the world. But every country in the world has a 747, has a fleet of 747. Has a fleet of 747. Even Bangladesh has its own fleet of 747. So what did they do with this international piece of machinery by analogy? They would dress it up, they would package it. So in the same way, they would have air hostesses who would dress themselves. And to me, all the skyscrapers that we saw when we first started have a multi-story thermal glass, because they just have thick walls in which the environment inside is totally steam. So about 8 years ago, we said, well, there must be a better way to do skyscrapers. But then someone has to do it. So we said, well, if we have to do it, we have to do it in a better way. Now, of course, the analogy is to perhaps, in building in the tropics, like an umbrella sort of architecture where umbrella is probably one of the best analogy we have for rock fish in the tropics, where it gives shading from the sun, keeps out a bit of the rain, and yet lets the wind through. And so we started to look at different categories of spaces, if you like. Side totally separated. And of course, in open sky spaces, you have different categories where you have louver spaces where the wind goes through, or canopy spaces like what you have here, where the wind goes through the side, and transitional spaces where in-between space between this and outside. So we started to layer the spaces between the inside of the building and the outside of the building. Then we started to look at other analogies, and we found that ants build skyscrapers too. In fact, ants are much better engineers than we are, because ants build skyscrapers over 1,000 times their own height, whereas we build skyscrapers only maybe about maximum 300 times our own height, maybe 400 times. But the other thing I noticed is that ants build skyscrapers in relation to the climate of the place. Now these are two ant hills in two different climatic locations. So ants already know how to use sun shading, steep roofs, and we are just beginning to learn how to do it in our architecture. So we start to look at the sun paths in different parts of the latitude. And so the equator, we are about almost east and west, and it gets sort of more heart shape towards the north. And of course, the shape of the building, the preferred shape, so it should change as you go upwards. So near the tropics where the sun is most east and west, you want to keep the external wall minimum facing the hot side. The importance of sun during winter months become more important, and cross ventilation become more important as you head towards the equator. These are some solar diagrams that I did with John Fraser's students about 2 years ago, where they started to develop a computer model for me, for looking at the sun shading and sun paths to different parts of the world. This is Kuala Lumpur. The sun's almost overhead. Well, this is near Singapore actually. Kuala Lumpur is here. It's about 2.5 degrees above the equator. That's Singapore. Now, one of the major justifications of design of climate is really energy conservation. And so our proposition is that you're able to use building configuration through design rather than through mechanical devices to design a low energy building. But of course, low energy buildings is also a cultural lifestyle issue. And you can see that the richer the country, the higher it is the energy consumption. So it's not just you can lower energy consumption to a certain extent through building design, but essentially it's through lifestyle, which is the major way of saving energy. There are, if you like, three basic strategies, I believe, in designing low energy building. First one is through low energy selection of materials, component, and equipment. The second method is to look at the entire cycle of energy use, from extraction, manufacturing, production, distribution. Of course, the third is through energy efficient design, reduction of material use by design. At this stage, most of our work is really in this category. Hopefully, within the next 10 years, we'll cover the other two. But if you look into the way energy is used in the country, energy use in UK, 56% of energy use in UK are in buildings. So architects actually have an enormous say in the enormous power in saving energy. And if you look into the life cycle of a building, the majority of the energy used is over 65%. And so if your building is designed to conserve energy by building configuration alone, every kilowatt of energy that you conserve contributes to reduction of energy of the environmental impact of the entire cycle of getting that kilowatt of energy. Production, production, transmission, and utilization of the kilowatt of energy. So every little bit helps towards the environment. Now, when we look at tall buildings, the most starting point, and one of the most important starting point was this is a project that we are doing in Ho Chi Minh City. And what we've done here is locate the cores on the hot sides of the building. But by locating the cores on the east and the west sides of the building, we can actually reduce the energy consumption by the electrical of the air conditioning by at least 20–25%. Because these act as buffers between the inside and the outside of the building. Now, of course, by locating at the cores on the hot side of the building, on the outside of the building, we create a low energy building through elimination of the need to pressurize the lift shaft and the staircases. If you have the cores in the middle of the building, then you have to pressurize the lift lobbies, pressurize the lift shaft, and so it has an added capital cost as well as an added operational cost. By locating them on the outside, you don't have to pressurize the lift shafts, and so that reduces the energy cost. But at the same time, you have greater awareness of place. So, for instance, if you're on the outside of the building, as soon as you get out of the lift, you can see out. So you get natural ventilation, natural sunlight, but you know where you are. So for instance, when there was a power failure, or when they had a bomb in the World Trade Center, and the core in the World Trade Center were in the middle of the building, everything failed. The electrical system failed, the emergency supply failed, and people couldn't find the staircase. People couldn't get down the staircase. And the person who led the people down the staircase did it through his Indiglo watch, so which took them down the staircase. The other thing we conclude in trying to sort of design a low energy building, high quality low energy building, is that the curtain wall should be located in the positions that have the minimum solar insolation. So for instance, in this building, we located them on the north sides and the south sides of the building. But in this way, you could also tell the geography of the place by looking at the building. So when you look at this building, if you're drunk, this is, that's where the curtain wall is. That's north, and that should be the point the way home. Of course, the other thing is space making, because a tall building, there's a danger to become just a concrete tray in the air. So we thought, well, let's try and do something else to make them aware of the environment and to give them greater choice between the inside and the outside. That was the building that you saw earlier on. Sorry, this is in Kuala Lumpur. Yes. And so, if you have the cores on the outside, then you can look out and you can see where you are. And by also creating terraces on the outsides of the building, we're able to give a transitional space between the inside and the outside, so that people on the inside of the building have a choice to go out. And so in these terraces, we also located planter boxes so that we could green the building and put plants on it so that comes alive. But if you look into the plan, the principles suddenly started to emerge for us anyway, because we did this almost unconsciously. The cores are put on the east sides and the west side, hot sides of the building. So this is the service stair and the service lift. This is the main lifts and the staircase and the toilets. All these have natural ventilation and sunlight. And then when you get a lift, you can see out so you know where you are. And then on the hot sides, we located terraces so that people go out to these terraces. And then on the north face and south face, we face curtain wall. But what we found is that by locating the terraces on the corners, we were able to have full height sliding doors, because generally for high-rise buildings, we never use sliding window sections because of the bad water exclusion. We also have to use casement windows. But because the windows were recessed, we were able to use sliding doors. And that means when the air conditioning failed, they could adjust the natural ventilation entering the building through adjusting the doors. And the planter boxes, we had sprinklers which fed water, gravity-fed water, as well as fertilizers into planter boxes, so that the building became almost like a living organism. And this is one of the executive offices at the corner, and they're actually, this is where like one of those terraces are. Then we started to look, say, well, that's a great idea, cutting notches in the building. So we started looking into cutting big holes and creating places in the sky, or sky courts. So this is what we did with this project in Penang. We started to cut some holes into the upper parts of the building so that increases the places in the sky, increases the communal spaces, as well as the cross ventilation through the building. The building was completed sort of last year, and those were the sort of voids cut through the building. And that's a wish model, showing how we would like the plantings to be built, grown all the way down the front of the building. Hasn't grown yet, but I hope it will. These are the terraces that you see here going out into the to give an example of the pace we're working, we were given 1 month to do a complete set of 1 to 100 building plans for this project. I couldn't finish in a month. I took about 5 weeks. I nearly got fired from the job. But having done the building plans, the building was under construction, the internal staircase took me 3 months to design. It was a steel staircase. So, can you imagine that we spend more time detailing a staircase in the building than sort of building the building itself, because we had to get the building plans approved. Otherwise, they couldn't sell the apartments, and all sorts of marketing problems associated with that. Then we found that it's ideally if the geometry of the site, and you have to remember, for most commercial buildings we're working very tight and small sites. If the geometry of the site and the geometry of the sun coincides, that's fine, because then you can just put a regular building on the site. What happens if it doesn't? So then you have to correct it. So with this building, we had to put more sun shading on this corner and on the other corner to compensate for it. So for instance, north is here, north is up that way, and the site is this shape. That means if the excuse me. So if the building is rectangular in shape, then both faces, all 4 faces of the building, we get sort of solar insulation. So I mean, in this way, we actually justify the shape of the building. Having a curved wall here, because parts of the building facing exactly north and south will not get that much direct solar insulation. And this is a sort of 2-zone building. So the first zone lifts sort of up to here. Then we reclaimed the office floor and shifted the toilets over here, so that the efficiency of the upper floor will be better than the lower floors. Of course, there'll be situations where the shape of the site, the longest side of the site faces the hot sides, and so we have to shade almost the entire face of the building. This model was made by one of John's students, I think. John says the other thing we try to do is we thought, well, why don't we have a wind scoop to try and sort of bring wind into the upper parts of the building. So these are 2 propositions. One is to have a single large wind scoop, and the other is to try to have orifices in the building so we can get wind into the inner parts of the building. Wind speeds at the upper parts of the building are able to get as high as 42 meters per second as maximum gust. So this building is completed in 1885. So we try to have this big sort of hole cut in on the outside of the building, so that try and get the wind through. Like this, so scoop. And that's looking up, and to let hot air out, we have to do this at the top. And where the glass faces the inside of the building, we are cutting more. And then we have terraces to try and make life in the upper parts of the building more than just a concrete tray, and to give variety and visual contact between the people from the upper parts of the building and the lower parts. So at that time, we were still using masonry in most of our projects, and so this was 1985, designed in 1979. Then I had a conversation around 1986 with Kurokawa, and I said what I wanted to do was to bring planting up the building. So I suggested, well, why don't you look at the Tower of Babel 4 years ago, So I said, right, what if Tower of Babel's really also spirally going up, so that's a great idea. Because ecologically it's much better to have continuous planting if you can, because then that encourages species interaction, rather than just have planting sort of like quarantine from each other. So we thought, well, why don't we have trellises climbing up? Because planting climbs up very easily through the trellises. And And so we thought we have planting starting from the ground, creating up the sides for building, crossing in between, and going up the other side of the building. So that's what we did with this project. The first building did by Yeang, where we got the planting up as high as we could, up across the floor, and then goes up again on the other side. And here's the detail of the planting at the corner, or the lower corner. This is where the planting turns around the corner, goes up again. And the sun shading is much more changes in depth. This building is completed. This was completed in 1986. You can see the plantings are coming out here, goes across. And then at the other side of the building, so comes up again. We wanted to put more planting in, but we couldn't convince the client to do that. So this was as much as we could. But with this project, you can see the geometry of the site. The geometry of the sun didn't coincide. Then we position the core following the geometry of the site to make the car parking more efficient. But by shaping it this way, we're able to cantilever some of the upper floors. So on this side, we cantilever the floors on this side, and on that side of the building, we cantilever the floors on that side. So the floor area of the building increases as you get to the upper part of the building, which is the part of the building that the rest are closed anyway. So that's here's the floor plan. You can see the floors on the hot side again. And, the floors will twist out as it goes. They'll twist out here, on this side, and twist out here. So you can see how the floors will shape in the other parts of the building. And then this is the shape of the site, which is almost squarish. The typical floor is orientated north-south this way, so the floors are orientated here. Again, you have natural ventilation and sunlight to the staircases. Then, with this project, which is now under construction, north is that way, so the logic position is on this side. But the client said, well, this is the main street. This is where I could sell. This is my best view. So I could locate all the cores on this side of the building, and we have to sort of recess the windows to give sun shading to the back of the building. It's under construction about so this floor down, and we have one cross bracing for every 3 floors. This is a cigarette pack site, so thin and slim. So back to the Tower of Babel again. So we thought, well, let's really complete this idea of a circular building with inspiring planting. And that's when we did this building, finished in 1992. This time we wanted to mount the planting up the building. So we had a discussion with the landscape architect, and she said, well, about 36, 37 degrees would be about right. So anything more than that, the erosion, the rain, the tropical rain will just wash the turf and the planting away. So we mount up about 36, 37 degrees, put the lecture rooms here, and then the auditorium is here. And these are the office floors. These two are the executive floors. That's the gymnasium, and the swimming pool, and the deck is on the top. That's the sunroom. That's the model of the building. So you can see the planting coming out from the sides of the building. And the building was designed in 1989 and completed in 1982. That's a completed building. So we had been fairly faithful to the model. This is, you can see the terraces spiraling up. But most of the time we have to try and sell the idea to the client. So when we did this design, we worked with a client who wanted a building which was initially 65,000 square foot that could expand eventually to about 85,000 square foot. So we said, well, there are a number of ways you could do this. One is to sort of, pile, to allow you to build extra floors later on. Or another way is to expand sideways. And in our discussion with him, he suggested, well, why don't we have interstitial spaces that we could fill up later on? We finished this in 1992, but this was the beginning of our second series, because in the first series we read individual buildings with individual ideas, and here we brought all these ideas into one single building. The idea of spiraling, of planting, and we had much larger terraces this time, and with sun shading. So you can see the planting coming out, and the terraces, and the sunroof. This is the deck at the entrance canopy, so that, so the auditorium's above here, and after the lecture and presentation, you will come down and walk into this and have coffee and walk into the deck, which overlooks the forecourt, and that's the entrance of the building. And that's the inside here. There's the glass wall, and so the mezzanine floor, you walk through this little gap into this bridge into the deck. This time we had much larger terraces than the other building. And so we had several sliding doors on both sides with greater control of natural ventilation into the inside of the building. And what we did was that we proposed that all the partition offices should be in the middle of the building rather than on the outside of the building. The first thing that anybody does, moves on the floor, is to put all the partition on the outside of the building. I said, oh, that's terrible, because then the majority of the people, the clerks and secretaries who use workstations, never get access to a window. So I thought, well, you should put all the sort of, executives in the middle and give them glass, full height glass, so they can see out and get sunlight anyway. And they're never in the rooms anyway. So I thought I'd put most of the people in the workstations on the outside. Of course, you could have some against the outside wall, but let most of the people have access to a window. And so this is the detail of the skyscraper. So every floor has a sort of 3-story atrium looking up, so stepping up. And figures have shown that if you ask people what would they like to control in the internal environment, lighting level, daylight, air movement, heating, cooling, temperature, noise distraction, be able to move the furniture or air freshness, an overwhelming 60% say they would like to control air freshness. Now, whether they actually open the window or not, get access to a window or not, or, regards to that fact, 60% say for peace of mind, they would like to be able to control the air freshness in the building. And so in this sense, a naturally ventilated building is an indication of the way to go for the future of the tall building. And this is how it looks like from the inside, going out to the terraces, and this is the other side of the building. In case the air conditioning doesn't work, we have this with air conditioning. Staircases encased, and we took out all the cladding from the escape stair, but it's cheap to build, and the escape stair is only used in terms of emergencies anyway. And here's the detail of the sun shading, and this is the catwalk to clean the windows. The other proposition is to have open to the sky space at the ground floor, so the transition from the outside into the inside of the building is gradual, so you don't just walk to the building and hit the glass wall, but you go into a sort of naturally ventilated lift or lift lobby before you enter the building. This is a project that we are proposing in China, Tengku. It's building in Abu Dhabi. So we start to look at, from sun, we start to look at wind and see how we could use wind to ventilate and to create energy. The wind rose in Kuala Lumpur is about, this is the wind rose in Kalijaya. not very reliable wind data, but what it means is that you get wind about 38% of the time, mostly from the east. With this project, what we did was to pull the apartments away from the corridors so that we had cross-fluent ventilation on the insides and around the building to try and create sort of apartments which is almost like a detached house in the air with bridges of linking the apartments. So these were the wind studies done by Phil Jones at the University of Cardiff for us. So these were the apartment buildings, about 30 stories. And you can see that this is the corridor going all the way down. Cross ventilation through this side and through that side. I saw this in Singapore in one of the housing boards, and I thought it was a great idea. So you have louvered walls, so you can control. You have 3 levels of control. You have glass, you have balustrades, then you have louvers. So we thought we would put this on parts of the building. Then we did this project in Haikau with Chris McCarthy to look into this drawing is actually done by Chris, and he suggested that wind speeds actually change as you go in the upper parts of the building. That you should actually have different systems at different heights of the building. For this building, it's an office building. You can see the hot sides are on this side, so we put the sun shading. Most of the wind comes from this side, which is northeast. And so Chris suggested we have 2 systems, one for the tenant areas and a separate system for the public areas, which is the lift lobbies. This is where the lift doors are, staircases, and you can see that this again is a 2-zone lift system. The first zone lifts serves up to here, then we cleaned off the space, shift the toilets. And that's looking at the other side of the building. And this little scoop at the top to try and catch the wind, and that's a revolving restaurant. That's a detail of the transfer where we change. Incidentally, I have a large number of XA graduates working for me. This is designed. ideas that we did earlier on. We look at temperature, wind direction, and we also look at some different Japanese festivals and different activities, so that we have different and the cones take on different colors at different seasons of the year. Different things pop up and down, sort of screens of the wind gets more intense at certain times of the year, so screens sort of pop up, sort of, to shield the plaza. The umbrellas sort of start opening different times of the year, and tops of the cones get sealed up or open. And inside the cones we have sort of levels which look out on the space. Also some fabric, covered with fabric, so that we can have projections on the cones and see on the outside, and the umbrellas on the outside. That's sort of spread out. This will conclude the basis of all our work. Essential justification really for tall buildings is land use. If you look into the percentage of the country that's covered in forest, Italy, only about 20% of the country now is left in forest, whereas we're still about 63% Malaysia. And so forested land becomes very precious. And to me, the future really is a high-rise future, like it or not. If there's going to be a high-rise future, then we have to start to lay the foundations now for the future. So the bioclimatic high-rise at this stage, which is only part of our agenda for ecological tall building, is really a climatic approach to design, the density of the society to enabling low energy and high quality tall buildings. Big question. And so that becomes a problem. We have to fight with the fire authorities to say, the fire authorities say they want 7.2 meters between the building and the boundary. We can say the fire engine is only about 3.5 meters maximum. So how to get a bigger footprint and how to avoid having to give fire engine access to the outside of the building. When you can say, look, if that's a fire, you can get access to the building from the front and the back, and that's sufficient. And so these are some of the things that we have to resolve with the planning and the fire authorities. So to answer your question, greater connectivity visually and physically between the ground floor and the upper floors, greater connectivity between the outside of the street down to the entrance of the building, and thirdly, greater connectivity between buildings are some of the things that we should be doing for the pedestrian, at the pedestrian level.
What sort of quantity of people are you using?
We take a ratio of about 15 square meters per person. Lift manufacturers take 15 square meters per person as an indicator of the population of a building. So that varies. I mean, lift manufacturers take 15 square meters, but in Asia it's probably something about 10 square meters per person. So the average net area, let's say in the 40-story building that we did, net area is about 40,000 square kilometers, 40 square meters. And so 40,000 square meters divided by 15 square meters would give about 2,000 to 3,000 people. Yeah.
And how do you deal with private cars and things like that, and transportation for those people who elect?
Right. That varies from country to country. Generally, the index is that you have to provide car parking of 1 car per 50 square meters of net rentable area. Okay, so now if you don't provide it, the authorities require you to pay for it. Pay the equivalent of 5,000 US for car parking that you don't provide. So it's ridiculous because then you're forced to either pay. Then they want to say, well, if I have to pay for it, I might as well build it, right? Because it costs about that much to build it anyway. So if you build it, then it encourages car to come to the city. So it's a vicious circle. Sorry.
The future for buildings is naturally ventilated. What steps are you taking, and how soon would you think that this can be achieved to get the total naturally ventilated for buildings?
Well, there are probably about 2 or 3 groups in the world looking into a naturally ventilated skyscraper. That's Uli Baer in Germany from HR Technik, who's actually done a lot of research on naturally ventilated tall buildings. There's Rowan and Williams in Canada, who's they're engineers, and they are looking into naturally ventilated tall buildings with us. We're also looking to naturally tall ventilated buildings with Chris, Better McCarthy. Well, let's say that naturally ventilated tall buildings is possible. You can get it now, but the level of control that you have compared to air conditioning, we still don't have it yet. You still have to sort of move around, and so every 10 minutes, climate isn't as consistent as air conditioning, mechanical, so you have to constantly adjust depending on the outside conditions. In my own house, where it's supposed to be a naturally ventilated building, it's all right if if it's every 20 minutes I have to start adjusting the doors, just to get this sort of environment right. And then when I have more than 6 people in the house, the body heat affects the natural ventilation. So these are some of the things that you have to consider. Yes, sir.
It seems to me that in the IBM building, there was a conscious effort to infiltrate the building with the popular street culture of eating out.
Right.
Do you not continue that in your other buildings as a way of not alienating the ground space under the building?
Yes. Eating out. You're talking about eating out, no?
Yeah, kind of Malaysian activity.
Well, actually, we found that with the Bowstead building, people actually use the terraces to have lunch. In fact, some of the terraces are so big that people actually put umbrellas and little tables, like in a cafe. I was talking to Herman Miller 4 days ago. They have a special research and development department, and the man who runs it is an architect. And we were talking about how does this affect the individual in a building. And I think it affects the individual in the following ways. I think the tendency now is for individuals to have greater choice rather than live in a concrete tray in the air. I have a Japanese architect friend, Dr. Ikeda from Nihon Sekkei, who's trying to design an office building in Japan so that the occupants could experience the 4 seasons of the year in Japan, because the Japanese are very proud of the seasons. And if you don't have the seasons, then you could be any time of the year. And so they're able to experience the seasons of the year, they're able to have choice and control of fresh air and spatially to move from inside to a transitional space, or several layers of transitional space, I think is the way to go. Secondly, I think the tendency now in most office buildings, the current, what's happening in office buildings, during lunchtime and mealtime, everybody goes down the building and goes to a canteen or goes out of the building. I think there will be, future office building would have eating stations in every floor, so dispensing spaces where people just go and eat and meet or have coffee. So probably near the lift zones, because that's where people meet. So that's some of the trends I think will probably happen in the future. Sorry, yes.
I'd like to know is your response to environment, do you have plans like from moving from reactionary level of reaction towards the environment and moving to a state whereby you can actually be proactive towards the environment and contribute? I mean, like create new activity in space.
On the activity in space, yeah. Sorry?
Repeat the question.
Yeah, could you repeat the question,
No,
please?
they won't hear out there, just you.
So, could you repeat the question so that other people hear it?
Yeah, what I'd like to know is like the reaction towards the environment in that part of the world. If you move from a more reacting towards the environment as a response, and moving further to more proactive response to the environment. And in this, I mean, whereby the environment starts to contribute different use of activities and use of space that is very different from just sunshading the building and going further than that.
Right. Yeah, trying to create a new form of internal life is something that we should all be trying to do. I believe that if you're able to create a new form of building and create a new form of internal life, you actually create a new architecture. So we're trying to find ways in which you could create internal life. An interesting sort of ideas happening now in Japan, in the IBM building in Japan, is that there's a concept called hoteling, where nobody has an office. As soon as you enter the building, you clock in the reception, and they assign you a workstation. And that whatever messages and phone calls to you gets directly to the workstation, and faxes and material and correspondence and everything else. And then, for the period of time when you're in the building, you use this workstation, and then after that, when you leave, you clock out again, and that workstation is assigned to somebody else. So in this way, you have a smaller building to serve a larger number of people. So that's that's the trend to go. But the other day, I was talking to somebody from Arthur Andersen, and Arthur Andersen, is probably one of the largest spatial requirement consultancies in the world. And they say that none of the existing workstations that have been built that are available in the marketplace meet the requirements. They say they need a workstation that they can put together within 24 hours. They need a workstation that they can take apart from one country to country, and the whole series of criteria. And said all the workstation design, all the system furniture available today, do not meet the requirements, and that it's not likely to be available in the marketplace in 5 years' time, unless somebody starts designing these workstations. And so in fact, that's a very big need to design internal furniture for office buildings. Somebody has to, we should really look into that. Yeah.
Last question.
Yeah. Yes, sir.
At the beginning of your talk, you mentioned that there's 3 areas you're interested in. And today you only talked about design.
Yes.
The other 2 are to do with embodied energy and materials and basically materials.
Right.
The later buildings you showed looked as though they were becoming more and more alive,
right,
relating to the environment. I love the idea of the shield popping out.
Right.
In your research now into materials, the materials you showed look as though they have the embodied energy in the metals and glass, which
Right.
is immense.
Right.
So, in areas, say, like Kuala Lumpur, is sustainable hardwood becoming cheaper? And do you imagine your buildings being built with shades in natural material?
Well, probably not with hardwood because, they
Sustainable hardwood.
sustainable hardwood. Most of sustainable hardwood, I think, comes from outside Kuala Lumpur, I
I
think.
don't know.
Yeah. So I think with aluminum, we have to use, for sun shading, we have to use solid aluminum rather than the sandwich aluminum, because the sandwich aluminum panels have a rubberized sort of layer inside that makes it less recyclable because of great impurities. And so we should try and use material which are not composites. Doesn't matter about
Do you have aluminium in Kuala Lumpur?
Oh yes, oh yes.
You do?
Right,
Are
yeah.
Are you looking at recycling that?
Yes, yes. And so for instance, the easiest material to recycle is actually the external cladding and the sun shading, because you can just take it, you just take the whole, remove the whole lot and recycle it and recoat it actually,
But my argument really is I see the frame or the structure of your building may be lasting, I don't know, 70 years, 80 years.
Right.
Gradually the shields and the bits changing and have shorter life cycle.
5, 6 years, yeah.
Yeah, you were mentioning that 60-year
Right.
life cycle of a building, you can necessarily be doing that.
Right.
And once the frame is established, then other things can be applied or taken off
Right, yes.
and die and everything.
Right.
Is that the way your research is going in the material?
We're trying to look into different parts of the building with different sort of life cycles, yes. Yeah.
Just very
Yes, Chris, yeah.
I'm very pleased to see the work, and especially the latest work,
Right.
where I also see the variety of shading systems, which I think are very exciting, not to go for a single solution on one facade,
Right.
but to break it up, and I think there's a tremendous amount of development there. But knowing your office and the way that you travel worldwide, and you have an international office, could you give us an insight into how you think your office may develop with eyeways and communication? Do you see that, what do they got to offer to your office, the network of communications?
Right. Well, bit of price really. So like wind tunnel tests. For instance, if I get a wind tunnel test done in Canada, it costs you an arm and a leg. Whereas I think wind tunnel tests in Australia are so cheap now because if we're going to get wind tunnel tests, we go to Australia, but what it means is that our way of practicing has totally changed with the introduction of the fax and the modem. 20 years ago, we didn't have the fax. You have to see a client, you have to sort of, travel all the way to see him, see him for about 20 minutes, and say, I don't like it, then go back again, and sort of, redraw it, and sort of, for the next time you see him again. But now you can just fax it to him. And in fact, we work with Chris on the China projects, and that, while we're sleeping, he was faxing things to us because of the time difference, and when we got it, and we faxed it back to him while he's sleeping, and so, within a week, we're able to sort of, complete, enormous amount of work together. So the fax machine actually has radically changed the way we work. And of course with the modem, we can now talk to different computers. We're doing this hotel in Australia now, where we just sort of, modem our drawings to the architect that we're working with in Australia, and then he would fax back the alterations. And so in this way, we're working much faster way. But obviously when fiber optics are become commonplace, then, we would have, we would speak through the phone and look at each other, and then I'll say, who's that strange woman standing next to you, or something like that. So effectively,
is there not just a paradox in that,
yes.
which is that the very justification for the offices, the idea of the IBM terminals, they come in and
right.
are assigned to whatever,
yes.
but the very purpose of bringing people together in those offices is going to dissolve as a result of the very communications that you're talking about. That the kind of aspirations for the Boeing 747 may not have that much longer to go with the advent of those very communications.
Well, actually, we just had this same conversation, last weekend in Fukuoka. Kurokawa's view is that nothing can substitute person-to-person contact. At the end of the day, so people still like to meet each other, to affirm relationships, to affirm, certain points. Even though you can do so much through the through the through the phone and through fax machine and through video phones. Person-to-person contact, might even become even more important as a result of distancing through working, through machines.
Leslie, the last question.
You're working in building, I assume, mostly in tropical countries.
No.
Is that for warm climate?
No, I mean, we're working in China, which is Beijing, which is temperate, cold climate.
So then my question is it not quite different if you're working in a country where climates can range, like in Canada, from 30 above to 30 below?
Yes.
I mean, it must be very different.
Right. Yes.
What kind of
You
building?
have to deal with hot summers and cold winters. Yes.
Yeah.
And mid seasons as well.
Is it more than just, it's just more expensive?
Oh yes, absolutely. Yes.
Yeah.
Right.
I guess I'm just opening up the topic just to,
It becomes more complex. Yeah.
comment on it.
Yeah. And then in some areas you have to deal with earthquakes as well. And so then you have other problems. And then not only you have earthquakes in Haikou, we have typhoons. And so you have climate. And then
So are then the design of the buildings in different climates evolving differently?
Oh, yes.
I mean, with the same concepts, but different,
Yes.
visually.
Hopefully, yeah. Yes, ma'am.
In your designs, you mentioned that you bioclimatically considered wind and sun.
Yes.
But I see to your work you're pretty much engrossed in getting plants crawling up to your buildings.
Yes.
How does these plants have an impact bioclimatically to your buildings?
Well, the idea grows on you. So anyway.
Had that worked out?
That worked out, yes. No. No, sorry. Plants actually work in three ways. First one is that they absorb carbon dioxide, carbon monoxide, and give out oxygen. So it contributes towards a healthier environment. So that's the first thing it does. Secondly, by releasing oxygen, it cools the environment near the building, so it contributes towards a much cooler, facade of the building. And thirdly, aesthetically, people will prefer to have to see planting rather than see sort of inorganic material, and so that's why we brought the planting into the building. A friend of mine thinks, King Soon from Singapore thinks that we should cover at least 75% of the facade of the building with planting. So I haven't been able to do that yet, but that's this objective we should be doing. To be effective, we have to cover at least 75% of the facades of the building with planting. But I mean, like BP, saying, that to be effective, you have to cover, 80-90% of a building with solar cells to be able to meet 60% of the energy requirements of the building. But I mean, if you do that, it'll be enormously expensive. So some sort of trade-off will have to take place, between how much of the external wall of the building you cover with planting of solar cells.
Yes, you were talking about all the time about healthier buildings and healthier environment. Where do you see the social relations in your buildings?
Social relations.
Yeah.
Okay.
Because you have buildings with 3,000 people, 4,000 people, and that's it. Do you think?
Oh, I see.
Do you know what I mean?
Yeah. What we try to do, I think I know what you mean, is that, do I think about how people use the space? Well, we started looking into the way space are planned inside the building. We're now saying that maybe, there are certain things we're trying to do. For instance, that we are proposing that for single tenancies, the access to the toilet should be direct from the floor rather than through the lift lobby, so that there's greater privacy. There should be larger communal spaces, which we call sky courts, so that people could meet in the upper parts of the building instead of coming down to the ground floor to meet. Lift lobbies should be much larger, rather than the minimum spacing of 2.9 meters between lift doors, and that maybe lift lobbies should have sort of vending machine space or eating space, so that people go there and buy the drinks and meet and interact. The idea is to try and create spaces in the sky which try and recreate, if you like, the conditions at the ground level, so that spaces in the sky are much more than just a concrete tray in the sky.
Let's then continue discussion informally. I must say that Ken's work is changing so quickly that I look forward in the certainly next year to hearing how it itself has grown. Thank you very much indeed.